It's quite a week. My name is Paul. This is my friend Bijeta. We work on Amazon S3, and our job today is to brief you on everything that the S3 team has built over the course of the last 12 months. We're going to cover 20 launches in the 60 minutes that we have together today. It's a lot. We have more content than time. And so we're not going to be able to dive as deeply as we would like into every single one of these launches, or else we'd all be here for 4 hours. But we will stay for as long as it takes to answer all of the questions that you have out in the hallway, down in one of the cafes, whatever it takes. We want to make sure that you all have the details that you need to put some of these new capabilities to work when you go back home after the show next week. So we've divided the talk up into 5 categories today. Those are performance, security and access, open source, observability, and backup and archive, okay? So as I mentioned, we have more content than time, so let's get started with performance. Now, when we invented Amazon S3 in 2006, its primary use case was the storage for the internet. Thousands of customers stored videos and pictures and other static assets in S3 to power websites around the world. And this is still a very important use case for us, but over that time, you all have led us in a completely different direction as well. Today, some of our primary use cases for S3 are around analytics, machine learning, and AI. And for these workloads, performance and storage latency are critical. And so over the last couple of years, the S3 team has really been diving deep into what it would take to make S3 faster, more performant, and lower latency, which is why we're so happy to have announced yesterday in Adam's keynote the launch of Amazon S3 Express One Zone. Express One Zone is a new high-performance storage class in S3 that delivers the fastest object storage in the cloud. It delivers single-digit millisecond first byte latency to power compute-intensive and latency-sensitive applications. An important design tenet with this storage class was not only to deliver this low latency storage, but to deliver it very consistently to eliminate tail latencies. This is critical for many of your analytics workloads that are highly sensitive to those tail latencies, and we'll talk about that a little bit more in a minute. S3 Express One Zone delivers data access speeds that are up to 10 times faster than S3 standard, along with up to a 50% reduction in request costs. Now, this is a very different performance profile than you're used to with S3. And to achieve that, we really had to take a step back and reimagine the S3 stack. We optimized the system up and down the request path for performance. And whenever you give us an object for Express One Zone, we place that object on high-performance storage media. These details down in the infrastructure, though, are what we consider to be fundamentals that you don't really need to worry about. What you do need to worry about, and what you do need to understand, is one very fundamental difference between Express One Zone and the storage classes that you all have been working with over the years. And that difference is the introduction of a new bucket type in S3. Now, this is a big deal for us since we've ever only had one bucket type. An S3 bucket has just always been just an S3 bucket. With Express One Zone, though, we introduce a new bucket type that we call a directory bucket. As I go through the details on directory buckets, you'll begin to understand why we introduced it and how it helps to accelerate your applications. And how I'm going to take you through it is to explain the 3 principal differences between directory buckets and the general purpose regional buckets that you're used to. First, directory buckets allow you to place data in a single availability zone that you specify. Second, there's a different request scaling model for directory buckets. And third, there's a different authentication model. Directory buckets are authenticated based on session instead of on a request-by-request basis. So let's dive deep into each one of these so you can understand what this new primitive means that we've just introduced yesterday. With S3 Standard or S3 Intelligent Tiering, when you give us an object, behind the scenes, we distribute that object across multiple availability zones. Availability zones are independent data centers separated by miles, connected by high-speed and highly redundant network connections. And we do that distribution before we return a 200 success response back to your application. This is all done in line. And this has great resilience and availability benefits for your applications, but the speed of light between these data centers does add latency to your requests. And so with a directory bucket, you're able to specify a single availability zone in which we store all of the data in that bucket. This cuts out the latency associated with distributing across multiple AZs, delivering lower latency storage to your application. Now, there are two principal architectural considerations that you need to think about as you move to this one zone storage. The first is that AZ placement for S3 is now a thing. Previously, or with regional buckets, you give us an object, we handle the placement across availability zones behind the scenes on your behalf. Now, with a directory bucket, you have the opportunity to co-locate your data right next to your compute. So you can shorten the network path between compute and storage and wring latency out of the system and make your applications faster. The second thing is that one zone storage does have a different durability model. And this is an important distinction for builders to understand, and so I'm going to take you through that now. Now, we offer 11 nines of data durability for S3 Express one zone in a single availability zone. And it's super common for customers to ask me what this means, since we're all so used to a multi-AZ model. And the best way to explain it is to kind of take a step back and talk about how we do durability in S3 in general, right? So I'm going to do that, and then we'll loop around and talk about the difference. The first thing that we do to deliver 11 nines of durability is we make sure that objects land on storage correctly. And to do that, we employ a technique that we call checksum bracketing to ensure end-to-end integrity checking for your requests as they come into the system. We checksum an object at the front door of S3 when you hand it to us, and we checksum data on storage when we durably store it, and we checksum data as it passes through the system, and we make sure that the checksum on storage matches the one at the front door that we took when you gave us the object. This allows us to know that the data is correct on storage. Second, we always store data on redundant devices within the system. We store data in such a way as we're able to tolerate the concurrent failure of multiple storage devices without any impact to the integrity of your objects. Additionally, devices always fail, and so maintaining this redundancy is a big engineering task. You have to discover device failures when they inevitably happen and repair redundancy on an ongoing basis. And so we have large fleets of systems within S3 that do that. Third, we periodically sweep through all storage at rest with an independent durability auditing fleet that checks to make sure that data stays correct over time. This is there to protect on the rare off chance that something like a firmware error deep into the infrastructure causes a bit flip or something like that. It's highly unlikely, but it's not impossible, and so it's a durability threat that we guard against with that independent fleet. So these three fundamental systems are going on to give you 11 nines of durability in S3 standard and all of our other regional storage classes. They happen stretched out across multiple availability zones. With S3 Express one zone, it's these same systems, same people, same culture of durability running in a single availability zone to get you that 11 nines. What Express one zone does not protect against is the loss or damage to all or part of an AZ. Now, AWS has never lost an AZ before, and we have a ton of very smart people working to make sure that that never happens, but we can't stand here and tell you that it's impossible, and so you should take that into consideration for your architecture. Okay? So that is one zone storage, the first fundamental difference with directory buckets. The second fundamental difference has to do with the way that we scale requests with directory buckets, okay? With regional buckets, the way that requests scale is that you start with 5,500 read requests per prefix, and under load, we, behind the scenes, add additional transaction per second, or TPS capacity, to the namespace that backs your bucket. So with a gradual sort of linear organic growth of an application, the orange line is usage. The yellow line represents the capacity that we're adding behind the scenes. With a normal linear scaling, we sort of add capacity behind the scenes ahead of you as you scale. This gives S3 that elasticity and allows you to scale over time up to hundreds of thousands of transactions per second in the namespace that backs your bucket. However, if you spin up a big cluster of GPUs and increase TPS by a step function, you may scale faster than we're provisioning ahead for you, right? And what we found is that in transactional analytics and machine learning workloads, customers often want to do that. They want to spin up and they want to take full advantage of the compute that they're running right away. And so with directory buckets, we scale requests differently. Instead of adding capacity over time, with a directory bucket, you get hundreds of thousands of TPS provisioned instantly when you create the bucket. You can instantly scale to those levels when you spin up compute and come in and hammer on a data set. So very different model for scaling requests with directory buckets. The third fundamental difference is the security model. With regional buckets, you authenticate every single request. And this is great because it gives you a high amount of granularity. We can write very expressive policies in IAM and in bucket policies. It gives us a lot of capabilities to authenticate on every single request. However, there's some latency associated with that authentication. And over thousands or millions or billions of requests, that small amount of latency adds up over time. So with directory buckets, we introduce a new create session API. This allows you to authenticate a session and then amortize the latency associated with that authentication over many subsequent requests. When you authenticate a session, we return a token to you that you can include in your requests, and that token grants access to the entire bucket. We don't support prefix-level permissions, for example, with directory buckets. It's a session authenticated to the bucket. That session can be enabled in 3 modes: read-only, write-only, or read-write. Now, these are important details for builders to understand. This is a fundamental to how the system works, right? This is security, it's job zero. But we abstract most of this away from you in the SDK, so you don't need to worry about creating sessions, refreshing tokens, adding them to your requests. In the V2 SDK, we handle that for you. However, when you're writing policies, especially bucket policies, they look quite different because the data path, we authenticate differently along the data path. So this is a simple read-only bucket policy on a directory bucket. You can imagine what a directory bucket on one of your regional buckets looks like. If you were to write that simple read-only policy for that, you would do something like deny put object, right? You would write a much more expressive bucket policy in order to write that out. Here we have one action on the data path, and that is the action of creating a session. And so what you see in this policy is allowing the action of create session when the mode of the session is read-only for a given principal. So those are the 3 big differences for directory buckets, right? Now, we've talked a little bit about the high-level performance envelope that you should expect from Express One Zone. A little bit about what's going on in the infrastructure below, as well as some of the new primitives associated with directory buckets that help to accelerate the storage. But as someone who's spent their career in storage, one painful truth that I've learned is that actually storage performance doesn't really matter. What matters is the performance of the applications that we run on top of it, right? And we've had this storage class in beta for a number of months now and are seeing very good results in terms of performance benefits for AWS services and for partners, and we'll take you through those now. For Amazon SageMaker, we see up to a 5.8x performance improvement for loading times. For Amazon Athena, up to a 2.x performance improvement for query times. and for Amazon EMR up to a 4x performance improvement. I want to just point out here that especially when you look at Athena and EMR, where you're running queries for analytics jobs that fan many, many requests out to many objects that compose that query, this is one of those examples where the storage latency matters, but so does the consistency, right? So does the limited tail latency. And so I just wanted to call that out. We also had a ton of strategic partners participate in the beta window as well. And they report similar performance benefits. Cloudera reports up to a 20% performance improvement, ClickHouse up to a 30% performance improvement with reduction in cost, and Chaos Search up to a 60% performance improvement. And that's not all. Many partners participated in our beta window, which is great for customers because it means that S3 Express One Zone is available for many applications that you trust and use today. Now, when I explain the difference between a directory bucket and what we have today, the first question many customers ask me is, how do I get from here to there? I have petabytes in standard. How do I take advantage of these new directory buckets? And that brings us to the second launch of the day, which is an improvement to our batch operations system that we refer to as single-step batch operations. This new feature allows you to easily move data from a regional to a directory bucket. For those of you who are not familiar with batch operations, it's a batch processing system fully managed within S3 that can process thousands of objects per second. It's an easy way to run an operation against thousands or millions or even billions of objects within your bucket. Previously, in order to run a batch operations job, you needed to compose a list of objects to operate against, which we called a manifest. With this improvement, you don't have to do that. You can point batch operations at a prefix in your bucket and say, operate against that prefix. So if you want to copy objects into a directory bucket, you can do that at the prefix level now and skip the part where you figure out on an object-by-object basis what all objects need to be included. We've also built a purpose-built workflow for importing data into directory buckets to make this even easier to use. You can see that here in the UI of the directory bucket, that single one-click experience, and that is a simple import function that scales to billions of objects. It handles a lot of the details like retries and stuff like that, and it provides a nice completion report at the end of the process. So that is the performance section of our talk today. We talked about the launch of S3 Express One Zone, which we are super excited about. We talked about how we got there in terms of the changes that we made to the system to achieve this new level of performance. Some of the performance metrics that we're seeing from both AWS services as well as partners, and then an easy import function to get from here to there. So with that, we'll move on to security.
All right. In general, Amazon S3 is designed to meet the requirements of our most security-sensitive organizations, including the global bank, the military, as well as healthcare providers. Now, in this part of our presentation, we'll talk about some of the key features that are under this umbrella of security and access. Well, first off, let's start off with the three security best practices that we've been talking to customers for years. 1, encrypt all data. 2, disable access control lists or ACLs. And 3, block public access. First, let's talk about encryption. Amazon S3 provides you a number of options from the left, which is completely customer managed, going all the way to the right, which is fully Amazon S3 managed. Start us off, we have client-side encryption, where customers or you bear the entire responsibility. So you own the encryption key, you manage key rotation, and you're responsible for encrypting the object bytes yourself. Going a step to the right, we have server-side encryption with customer-provided keys. Now here, you own the encryption keys, and you use those keys at the time of uploading or downloading those objects. We're doing encryption on the server side, and we're removing that encryption key from memory. Going a step further to the right, we have server-side encryption with AWS Key Management Service, where you have control over the encryption key, and AWS hosts it. Along with this year, we launched dual-layer server-side encryption with AWS Key Management Service. Now, with DSSE KMS, you're able to meet regulatory requirements of applying multiple layers of encryption without actually investing in any additional client-side infrastructure. And all the way to the right, we have server-side encryption with S3, my favorite, which is fully Amazon S3 managed. Now, with that, we own the encryption key, we're managing key rotation, and we're doing the encryption of the object bytes on the server side, and all of this is at zero cost to you. Let's talk about that second best practice, disable access control lists, or ACLs. Now, ACLs were the original permission method for S3, so they were the only way you could grant access to both your objects and your bucket, and they were invented before AWS Identity Access Management, or IAM. Now, since the launch of IAM, that's become the de facto standard for managing permissions. IAM is more robust, it's easier to manage, it's easier to scale, and it's well integrated across all different AWS services. So for simplicity, we tell our customers to manage access through IAM policies or bucket policies and move away from using ACLs. And finally, that third best practice, S3 block public access. Block public access is a centralized way where account administrators or bucket owners can prohibit public access and have it enforced irrespective of how the AWS resources are actually being created underneath. So if Amazon S3 receives a read request in your bucket, we're actually verifying whether block public access is enabled on that bucket. If it is, we prohibit that read request. We reject that request. So here on the screen is what you would see if you go to block public access on the S3 console. Now, this best practice goes hand in hand with AWS IAM Access Analyzer. Access Analyzer is great because it provides you that visibility into unintended access into your AWS resources, like your S3 buckets, and it's free to use. So on this screen, Access Analyzer is actually warning me that 3 of my buckets are allowing public access using bucket ACLs. So here's when I would go in, inspect those bucket ACLs, and disable them. So to recap, we talked about 3 best practices. We talked about encrypting all your data, talked about disabling ACLs, and we talked about block public access. In 2023, we introduced bucket defaults for all 3 of those things. So starting off in January of this year, we introduced encryption by default with SSE S3 for all new and existing S3 buckets. What that means is for all new objects in S3, SSE S3 is now the minimum level of encryption. And this is at zero cost to customers. This was a huge deal for us. And we carefully rolled this out over months to ensure no performance impact across millions of customers. Then in April of this year, we introduced block public access by default on all new S3 buckets. Also in April, we disabled ACLs by default on all new S3 buckets. Now with those 2 settings, the bucket owner automatically owns all objects in their buckets. Now those of you who are builders in this room, if you're wondering how we did that, we actually modified the create bucket API to introduce those defaults. Note, however, customers can give access to data in their buckets using bucket policies or IAM policies if their applications require it. Now, 2023 may have been that year where we introduced all these bucket defaults, but this wasn't the first time that we did it. We've been simplifying access control for a while now. All the way back in 2020, we introduced S3 Object Ownership Preferred. And with that, the bucket owner became the de facto owner of all objects in the bucket. And they could disable ACLs with a client handshake. Soon after that, we introduced S3 Object Ownership Enforced, and with that, the bucket owner could outright disable all ACLs in their bucket. 2022, we improved visibility of ACLs by adding ACLs to your server access logs as well as CloudTrail logs, so customers could actually inspect which of their requests were still being authorized through ACLs. And all of that set us up to what we did in April of this year, where we disabled ACLs by default. Now, Customers agree with this recommendation. They want to move away from ACLs and rather use bucket policies or IAM policies. But first, they wanted to inspect which of those existing objects still had ACLs enabled. They wanted to look before they leaped. And that's why in July of this year, we added ACLs in S3 inventory reports. Now, this gives you a complete audit of all ACLs in your bucket. S3 inventory reports are great because they give you, they're very easy to configure, and they give you a very cost-effective way to get visibility across millions of objects. Now, we added a new field called Object ACL in your S3 inventory report, and this is alongside the 19 metadata fields that S3 inventory report already had. Now, with this tooling, customers are able to more easily review those ACLs, disable them, and migrate to using bucket policies or IAM policies. Let's look at what that looks like. Here's an example of an object ACL in an S3 inventory report. So the object ACL actually gives you visibility into the object owner, the grantee I'm giving permissions to, and the permission level. So in this example, we see status is available, which means an object ACL is actually available on this object. I'm giving permission to this Amazon S3 predefined subgroup called authenticated users, and the permission level is read-only. So to recap, we've been talking about why customers should disable ACLs and use bucket policies and IAM policies to manage permissions. But in some situations, especially in the case of data lake workloads, we've seen that even bucket policies and IAM policies can run into some scaling constraints. So let's talk about that in the next few minutes. Data lake permissions can be challenging. And here's why. Many different users will use many types of data in S3 for doing many different things. Here's an example of a data engineer running a data transformation job, maybe using Amazon EMR, on some data in S3. Now, you could model this through an IAM policy pretty easily. Let's add another data scientist running a different data transformation job using EMR, a different bucket in S3. And again, if you know what you're doing, it's relatively easy to model through an IAM policy. But what if I add hundreds or thousands of new users? What if I add many, many different applications? And these are query engines, dashboards, homegrown apps, all of that. You can see that the access can get pretty messy pretty fast. And many reasons why, right? For one, the scale is massive. Two, the frequency of change is pretty high as you're adding and removing users and groups from your corporate directories. And if you're somebody who's responsible for managing that access, you're considering a few things. First, S3 bucket policies, as you know, can scale up to 20 kilobytes. That's the max, right? Also, S3 bucket policies are monolithic, so it's really hard to go back and change that same monolithic policy every time you want to add something or remove something. IAM policies are great, and they get you that role-based access control, but not the kind of dynamic access control you would need in that sort of a situation. Also, IAM policies limit you to 1,000 roles per account. So you're always having to do the map between bucket policies and IAM policies. When you have different sorts of applications, you're also having to manage permissions across all of those applications in EMR, in Athena, in your homegrown app to say to make that mapping of who has access to what data. So there's all of that duplication that's happening across applications. And finally, auditability is very hard because even though in your server access logs you can see that this EMR job ran on this data and assumed this IAM role, you're not able to see which end user identity assumed that IAM role. And those are the exact 3 challenges that we work back from to launch S3 Access Grants. We just launched this past Sunday. Apparently, we're doing launches on Sundays. What's amazing about S3 Access Grants is that it's built for data lake scale. For example, we can give you 100,000 grants per access grant instance. Second, it's integrated with corporate directories, so you could map users and groups, including users and groups from your existing corporate directory. So this is Azure Active Directory, Ping, Okta, whatever you're using in your organization, to specific folders in S3. And finally, we've done the hard work of integrating AWS Identity Center with AWS CloudTrail so that end user identity, it actually follows through to your CloudTrail events. So you can see who has access to what type of data for which kind of application. Let's take a look at what an S3 access grant looks like. Here's an example of an S3 access grants instance. That's a logical grouping of all your individual access grants. And on this example, I want to highlight 4 things. Right on the left-hand side, we're seeing grant scope. So your scope can be your object, can be a prefix, or it can be your entire S3 bucket. So you could be as restrictive as you want. You have the grantee ID, which is your end user identity. You also have the grantee type. Now, this can be an IAM type, or it can be a directory group. And finally, I want to show permission, which is read-only, write-only, or read-write. Now, coming back to that complicated access mesh from a few slides ago, that's exactly the place where S3 access grants helps. So in this scenario, we have a bunch of users trying to use a homegrown app, which needs access to data in S3. Well, first time, we're going to check whether that access can be authorized using S3 access grants. If it can be authorized, S3 access grant returns back the least privilege, as well as the temporary credentials that the application or the end user can then use for their subsequent S3 APIs. So your get object, put object, all of that. What's really interesting to note here is that S3 access grant actually scopes down the credentials for the specific caller and the specific request. And by doing that, it's improving your organization's overall security posture. And that's not all. We've made some meaningful partnerships and integrations this year at launch. So we've already integrated S3 access grants with EMR, Redshift, IAM Identity Center, as well as CloudFormation. We have external partnerships and connectors with Immuta, Informatica, Spark, and Terraform. And we'll continue to make these integrations and partnerships all through 2024 to ensure that S3 access grants fit well into your ecosystem. And with that, we'll talk about open source.
So over the last couple of years, we've kind of had a shift in the way that we think about client-side experience. Historically, we've been very obsessed about the S3 API and providing a great developer experience with the API. It's an important API in the industry. Many people rely on it, and it matters a lot. And that's sort of been the boundary of our service as we saw it. But over the last couple of years, especially in data lake scenarios where customers are relying on more and more open source, customers have asked us to be much more opinionated on client-side experience. And in fact, we've come up with ways to optimize on the client side to make things better and faster and more easy to use for customers. And so what I'm going to take you through now are the open source updates that we've made in the last year or so, including some open source products that we've launched according to this new philosophy of really focusing on client-side experience. One thing that we introduced actually a while ago now is a component in the AWS SDK called the Common Runtime, or the CRT. Now, similar to what we've done on the security side where we've encoded best practices into the defaults for S3 buckets, what the CRT does is it takes the performance best practices that we've talked about at reInvent for years and builds them into code that you can simply adopt into your application. Some of those performance best practices are automatically operating multi-part uploads to parallelize your put requests, automatically doing range gets, multiple range gets in order to parallelize on the get side, and implementing interesting retry logic in order to spread retries out to many IPs on the S3 front end's fleet. These are things that we've been talking about for years, but now it happens automatically for you when you adopt the SDK. The goal of the CRT is to saturate the NIC of your EC2 instances without you having to go fiddle with performance tuning to make that happen. And when we do that, you can see very significant performance benefits with very little effort. And it makes it a lot easier to drive up the utilization on your compute. And so this is a cool, important building block, and we've been talking about it a lot for the last year. We talk about it a lot here at re:Invent. It's had real impact on customers, and I recommend that everyone take a look at this and see if you can integrate into your application. If you're not on the V2 SDK yet, this is a great reason to get there. But it's more than a building block for builders to build into their applications. We've gone and built entire products based on the CRT and based on the concept of automatically maximizing throughput for your clients. Most notably, we launched Mount Point for Amazon S3 back in August. Mount Point for Amazon S3 is a high-performance open source file client for S3. It allows you to mount a bucket up on your local file system, and it translates local file system API calls into S3 puts and gets. It relies on the CRT under the hood to drive very high single instance data transfer rates, and it's designed for reliability and not for POSIX compliance. I put this in here because it's a common question that we get about Mount Point. Customers ask why we would do this, because S3 is not a file system, which is true. And a design tenet for us on Mount Point is to not attempt to implement file system primitives that don't have a good analogy in the S3 API. For example, we do not support POSIX permissions. We don't support a Linux move command, these sorts of things. So our goal here is to deliver something simple, high performance, reliable, and supported by AWS. If you need POSIX compliance for your application, we have tons of file services within AWS to help you with that. So given that I just did 25 minutes on S3 Express One Zone, you can probably guess what the next slide is, and that is Mount Point support for our new high-performance storage class. This is an easy way to take advantage of Express One Zone. You can just plug in Mount Point tomorrow and start to test out this service. It delivers up to a 6x improvement in throughput compared to S3 standard, allowing you to really accelerate machine learning or other jobs using Mount Point. In fact, training jobs see up to a 30% improvement in performance when using Mount Point compared to S3 standard. So that's Mount Point, and then the launch yesterday of Mount Point for Express One Zone. This is what it looks like in our shell. And again, it's just a simple one-liner to mount up a bucket in user space on a directory in your file system, and from there, it's very easy to just access using the Linux commands and file system APIs that you know and have been using forever. Now, we've actually been developing this in the open. We have an open roadmap on GitHub. Mount Point is a completely open source product, as well as the underlying CRT is open source as well. And some common feedback that we've gotten on Mount Point was that customers like the concept of a simple, fast file client for S3, but they asked us to consider doing caching on the client side to accelerate even more those repeated read requests, which are common, especially in many machine learning workloads. And this is what we launched last Friday, automatic caching for Mount Point for S3. This reduces request costs and accelerates requests when you have repeated read requests using Mount Point. It allows you to read a file from S3 and then subsequently read that file from EC2 instance storage, EBS, volumes, or even from memory. This means that your first read is at S3 latency and subsequent reads are much faster. This can accelerate training jobs by up to 2x when we consider the impact of Mount Point, now with caching as well, when we have repeated requests in our training loop, okay? So that's the third update on the MountPoint side, and another bit of feedback that we've gotten from customers, especially for those running machine learning in containers, which is a very common deployment model within AWS. These customers asked about MountPoint for containers. Now, they could always run MountPoint from inside a container, but the packaging has not been convenient, right? And so we launched a new flavor of MountPoint for Amazon S3 in containers. This simplifies your architecture because it allows you to automatically connect S3 to a Kubernetes pod. It can be deployed as a CSI driver, as an add-on to your EKS cluster, and you get all of the features and performance benefits that we've talked about so far, only containerized. So this is where we are with the MountPoint family today. Starting in August with the launch of MountPoint, adding support for local caching, support for S3 Express One Zone, and support for containers. It's been a great story so far in terms of our ability to rapidly iterate based on your feedback. And again, the roadmap for MountPoint is public on GitHub, so we encourage you to check that out, and if you're inclined to contribute. Another important open source project that customers rely on today is PyTorch. PyTorch is a widely used machine learning framework that allows customers to drive machine learning training loops. And there are two data-heavy operations in PyTorch that customers asked us to take a look at to see if we can make more efficient. The first is data loading. So often what is happening when we load data for machine learning training is that we have a large cluster of instances spun up and waiting to get going. And so accelerating loading is critical to keeping those machines fed and doing the work that we want them to do. The second data-heavy primitive within PyTorch is checkpointing. Checkpointing is the periodic save of the model as we train it, right? And this is a very important and data-heavy primitive as well. And typically what customers have been doing with this is to drop checkpoints down, often to NVMe, and then asynchronously sweep those checkpoints off to S3 after the fact. This is cumbersome, it's complicated, and can impact the performance of the training itself. So last week we launched a new Amazon S3 connector for PyTorch. Based on the CRT, it delivers high throughput between S3 and a PyTorch training job, and it gets you up to a 40% improvement both on data loading as well as on checkpointing. So we're very excited to have that out there. So that's what we've done on the open source side, in addition to the contributions to projects like Trino and S3A and others. We launched a new family of products on MountPoint, with MountPoint, a completely open source file connector, and now a new open source connector for S3 for PyTorch. Next, let's talk a little bit about observability.
Amazon S3 provides you a number of tools for getting observability into your data. Now, this includes S3 inventory reports, S3 server access logs, as well as S3 storage lens. Now, we briefly talked about inventory reports in the previous section. In this section, let's focus more on S3 server access logs and S3 storage lens. To start off, I want to say that we announced in S3 server access logs date-based partitioning. Now, S3 server access logs gives you detailed visibility into all requests going into your Amazon S3 bucket, and it's free to use. What the date-based partitioning gives you is the ability to filter by time when you query the log data. So essentially, you're minimizing the amount of data scanned, you're making your queries more performant, and if you're using query engines like Athena, Redshift, and others, you're actually reducing the cost of running those queries. Now, for those of you in the room who's not used S3 Storage Lens, let me give a brief intro. Now, S3 Storage Lens delivers organization-wide visibility into storage usage, gives you activity metrics, as well as actionable recommendations to apply things like cost optimization and other best practices like security, encryption, data protection, et cetera, et cetera. Now, here's an interesting anecdote that I like to share. Customers that have used Storage Lens advanced metrics have obtained 6 times the cost savings, 6 times the cost savings than the actual cost of running Storage Lens advanced metrics in the first 6 months. Now, that's a bit of a confusing anecdote, but it's a great one. Let's look at what we've done in Storage Lens in 2023. We did 2 big things. First, we introduced activity level metrics at the prefix level. So this is aggregate request count by status codes, bytes downloaded, all of that at a prefix level granularity. So with this sort of a visibility, customers are able to make decisions like cost optimization at a prefix level. For example, if you're able to identify that the data in a specific prefix is being infrequently accessed, you could choose to enable intelligent tiering or move that data down to a colder storage class like Glacier Deep Archive and save some of those storage costs. Another big thing that I want to highlight in Storage Lens that we did this year is introduce Storage Lens groups. Now, with Storage Lens groups, you can aggregate your storage usage metrics. And these groups are actually custom filters that you're creating on object metadata. And this could be object metadata like the object age, file size, your prefix, suffix, tags, all of that. This is especially helpful when customers have shared data lake type of buckets. A practical example of this is if you'd be able to build better archival and retention strategies based on the age of the objects in your bucket. Let's look at what it would look like if you enable Storage Lens. Now, here's my 30,000-foot view. For my account, I'm able to see the total usage in my account, number of buckets, total number of requests, all of that aggregated in that top dashboard. On the bottom left, I'm able to see the storage class distribution, so how much of my data is in the warmer storage classes versus how much of that is in the colder storage classes like Glacier Flexible Retrieval, Glacier Deep Archive. On the bottom right, I'm also able to see how my data is distributed across the AWS regions. Now, we talked about the Storage Lens groups launch. Here's an example of me creating 2 Storage Lens groups, so one for reInvent presentations, another for pictures of my kid. And we've created these groups based on object metadata. So here we're looking at the file suffix. So all PPTs go into the reInvent presentations, all the images are going into the pictures of my kid. Now, what if I want to look at my storage usage over the past 7 days for those groups that I created? Now, I know this presentation is a big deal, and we have many versions of this deck. But also as a mom, I've uploaded way too many images of my kid, which is why the blue line is where it is, and the red line is down below. We talked about prefix reporting by activity. So here's that for you. We have each of my prefixes listed down below, and I'm looking at my aggregate request count. So my total number of gets, total number of puts. I'm looking at my percentage error rate, also the type of errors. Now, I want to highlight right at the bottom of this dashboard, I'm able to see that the percentage of 403 access denied has recently gone up for a specific prefix, bucket 3 presentation. So this is where I would go in and inspect that bucket policy and see what's going on there. Now, those were just a few examples of how you could use S3 Storage Lens and how you could do things like cost optimization, apply best practices, and things like that based on those activity and usage metrics. But there's a lot more to learn on Storage Lens. We have dedicated sessions, demos on Storage Lens at reInvent, and we welcome you to attend those. For the last section of our presentation, backup and archive, and I'll start us off with backup. Now, over the last few years, customers have been moving their applications from on-prem to the cloud. And with that, they've brought with them enterprise-grade level data protection requirements. So we've invested a ton in this area. Our philosophy has always been to take a building block approach. And the 4 pillars of our approach has been, First, S3 versioning. With that, customers are able to protect against accidental as well as malicious deletes. We have S3 object log, which is the de facto standard for immutable storage on S3. It also gives you that additional knob to protect against deletes as well as ransomware-like attacks or other malicious attacks. We have S3 replication, which is the fully managed automated way to copy data. It could be cross accounts, cross region. We have an SLA-backed offering called replication time control. There's a ton of metrics for monitoring. It's got a ton of flexibility. Finally, S3 multi-region access points. And that's the layer that's the layer that sits above S3 replication, and it's our single global endpoint that lets you route your request traffic across AWS regions. Now, in 2023, we've innovated in almost all of these areas. First of all, I want to highlight the fact that we've made it super easy for you to enable S3 object log on existing S3 data. We've also made it easier to enable replication for object log buckets. It's a single click, and it's super easy to get started. Second, we introduced an Amazon CloudWatch metric for you to troubleshoot and diagnose your replication configurations a lot more easily. We've added a new metric called Operation Failed Replication, and with that, you get per minute visibility into the total number of objects that did not replicate or make its way from your source to your destination. And finally, because a lot of our customers were copying data from one AWS account to another AWS account to protect against accidental or malicious deletes, we added the ability to also do S3 multi-region access points across accounts. We added cross-account support. Now, outside of all the server-side improvements that we've been making over the years, we've also been working more closely than ever with our backup partners. All the backup partners that you see on this slide, including AWS Backup, build backup solutions that work for your applications. And all of these are helping you back up the data from your Amazon S3 buckets. And with that, let's talk about archive.
So in 2023, especially in the first half, there was a big focus on cost optimization across the industry. You all took a close look at storage costs, so did we. You all moved a ton of data to Glacier, so did we. And that was great. Tons of storage costs has been reduced this year. And what customers are telling us about archive is that while they love the cost savings, they want to be able to put that data to work. And so there are really two places where we have been focused on making archive easier to use, especially when complementing your data lake architecture. So first, what we did is we improved Glacier performance, restore performance by up to 85%. This restore performance optimization happens automatically when you restore in bulk using S3 batch operations. Effectively, what we've done here is, since we know with a batch operations job all of the objects to restore up front, we're able to optimize as we thaw the data out of archive and drive higher levels of throughput. That's the first part. Additionally, we start to drop objects off for you earlier. Previously, when you did a bulk restore from Glacier, basically you would get all or most of those objects in 3 to 5 hours. Now, we'd start to drop objects off in minutes so that you can process data in parallel to the Glacier restore. Now, this is a little bit nuanced, so I drew a picture to help kind of tell the story on what this means for applications. Now, I'm using the backup use case here, but this is a common pattern across many use cases. With backups, if I have taken backups of a series of servers in my environment and I need to restore them, data gets corrupted and I need to do a restore, the workflow is first I rehydrate from Glacier, I restore from Glacier, and then once that data is restored, I go and restore back those applications from the recovered Glacier objects. With this new enhancement to Glacier restore performance, first we've increased the throughput on the restore itself. But then when we start to drop off objects earlier, you can start to do the work of restoring clients in parallel to the actual restore coming out of Glacier. So if we look at the total job to be done, in this case, restoring many hosts in my environment, that end-to-end wall clock time can be significantly shortened. Now, like I said, we're talking about backup and recovery here, but this is a common pattern for archive data, right? I may want to restore and then train, or restore and then query. In any of those cases, this sort of breaking that sequential model can help a lot if your applications can take that. The second thing and the last launch that we have to take you through today is Glacier support for Amazon Athena. Previously, when Athena saw an object in Glacier, it would just skip it. What we did was we added some additional information to S3 list responses so that you can see the Glacier restore status in the result of a list request. Athena integrated with this, and so it's able now to see if a Glacier object is restored online, it includes those objects into the Athena query. This means that you can use a single query to query across both archive and online data sets, and you can more easily use archive data to complement your data lake analytics workloads. So that was our 20 launches in 60 minutes. We talked about the launch of S3 Express OneZone, our new high-performance storage class for S3. We talked about an easy way to import data into that new directory bucket concept based on some optimizations in batch operations. We talked about new bucket defaults, a huge change to S3 that we launched early in the year, as well as the introduction of S3 access grants. I almost used the code name that we've been using for the whole year. Access grants. We talked about everything that we've launched in the open source space. A range of launches on MountPoint, as well as a new PyTorch connector for S3. And we talked about improvements on the observability side to storage lens and access logs. Finally, we wrapped it up with a range of launches that we did in the multi-region space, as well as an improvement to object lock, and 2 improvements to Glacier Restore, improved performance, as well as support for Athena. So thank you all so much for your support over the years. Thank you for taking the time to come to our talk, and please provide feedback on the session. We work backwards from your feedback on our products, and we work backwards from your feedback on reInvent as well. So thank you all very much.